Welcome to the Explainer. You know, when you're studying anatomy, some body systems just seem to get all the attention. But today, we're diving into the unsung hero that keeps your whole internal world in perfect balance, the urinary system. This is a super high-yield review, tailor-made to help you crush your exam. So let's jump right in. Okay, let's kick things off with a number that just sounds made up. 180 liters. That is how much fluid your kidneys, these two little bean-shaped organs, filter out of your blood every single day. I mean, to put that in perspective, that's almost 50 gallons. So the big question is, how on earth does your body manage that volume? And maybe more importantly, where does it all go? We are about to break down the incredible efficiency of this amazing system. First up, let's take a look at the major hardware. The best way to think about the urinary system is as your body's personal 24/7 purification plant, constantly working to keep your blood clean and perfectly balanced. You know, the actual hardware list is pretty straightforward. You've got two kidneys, and they're doing all the heavy lifting, filtering the blood, making the urine. Then you've got two ureters, which are basically just pipelines that carry the urine down to the urinary bladder, our little storage tank. And finally, the urethra is the exit route. It's just a beautifully simple and efficient design. But the real magic, the real action, is all happening inside the kidney. So if you were to slice one open, you'd see two main zones, a lighter-colored outer shell called the cortex and a darker inner part called the medulla. Now, the medulla is really cool. It's arranged in these cone-shaped bits called renal pyramids. And at the very tip of each pyramid, urine drips into a collecting area called the renal pelvis, which acts like a funnel, guiding all that urine on its way out. Okay, but to really, truly get how the kidney works, we've got to zoom in, like way, way in. We're going from the big picture organ level all the way down to the microscopic workhorse of the whole operation, the nephron. So here's the deal, and this is absolutely key. The nephron is the tiny little machine that does all the work, and your kidneys are packed with them. We're talking over 1 million nephrons in each one. For your exam, understanding the nephron is completely non-negotiable. So let's break it down. Every nephron basically has two main parts. First, you've got the renal corpuscle. That's the filter. It's made of the glomerulus, which is just this tangled up ball of tiny blood vessels, and it's wrapped in something called the glomerular capsule. A great way to picture it is like a catcher's mitt catching everything that comes out. The second part is the long, winding renal tubule. This is the processing line where all the filtered liquid gets fine-tuned. And now, for the main event. This is guaranteed to be on your test. How is urine actually made? Well, it's a beautiful, elegant three-step process that's happening simultaneously in every single one of those millions of nephrons.
These are the three words you need to know cold: filtration, reabsorption, and secretion. Let's walk through each one right now so you can see exactly how your body performs this incredible cleaning service for your blood.
So it all kicks off with filtration. Blood comes screaming into that glomerulus under really high pressure, and that pressure literally just squeezes water and all the small stuff like salts, glucose, waste products, right out of the blood and into that catcher's mitt, the glomerular capsule. This liquid that's been filtered out is called, well, filtrate. Okay, so this brings us right back to that crazy number from the beginning. If we're filtering 180 liters of fluid every day, why aren't we peeing 180 liters of urine? The source material asks this exact question, and the answer? Well, the answer is the key to understanding the most important step in the whole process. And the answer is reabsorption. As all that filtrate flows through that long, winding renal tubule, the body gets busy pulling back almost everything it needs. We're talking over 99% of the water, plus essential ions and valuable nutrients. They all get reabsorbed from the tubule and put right back into the blood. It is the ultimate recycling program. And this leads us to a super important clinical connection, a real high-yield fact for your test. In a healthy person, 100% of the glucose that gets filtered is reabsorbed. So if you ever find glucose in the urine, a condition called glycosuria, it's a classic telltale sign of diabetes mellitus. It means the system is just so overwhelmed with sugar that it can't grab it all back. Definitely remember that connection. All right, the final step is called secretion. Think of this as the body's last chance to dump any remaining junk. It's basically reabsorption, but in reverse. Things like waste products, certain drugs, and any excess ions are actively pulled from the blood and transported into the tubule to be added to the urine. It is the final cleanup crew. So we've got this incredible, mostly automated system. But how does the body fine-tune it? Like, what happens if you're dehydrated or you've had too much salt? Well, the answer is hormones. They act as the command center, telling the kidneys exactly how to adjust urine volume and composition on the fly. Okay, this table right here, you're going to want to screenshot this. It's perfect for studying. Let's just quickly run through the big players. If you're dehydrated, your pituitary gland releases ADH, the water-retaining hormone. It basically tells your kidneys, hey, hold on to water. If your blood pressure is low, your adrenal glands release aldosterone, the salt and water-retaining hormone. Because remember, where salt goes, water follows. And on the flip side, if your blood pressure gets too high, your heart itself releases ANH, the salt and water-losing hormone, to help get rid of extra fluid. It's all about that perfect balance, see? Okay, so the urine's been made, the volume has been adjusted by hormones. What happens next? Let's trace its path out of the body. All right, so once our final product, the urine, is ready to go, its big journey starts. It all collects in that funnel-like area we talked about inside the kidney, the renal pelvis. From the pelvis, it flows into the ureters. Now, these aren't just passive tubes. They're actually muscular, and they use these rhythmic contractions called peristalsis to actively squeeze and push the urine downwards towards its destination. And that pipeline leads directly to the urinary bladder. This thing is an amazing, expandable, muscular sac that's designed to store urine until, it's a convenient time to go. And finally, the journey ends. The urine exits the body through one last tube, the urethra. From the inside of the kidney to the outside world, it's a smooth, one-way trip. But how do we actually control this whole process? This is where two critical gatekeepers come in. The internal urethral sphincter is involuntary. It just relaxes on its own when your bladder starts to get full. But thankfully, we also have the external urethral sphincter, which is made of voluntary muscle. This is the one you have conscious control over, which lets you decide the right time and place. And let's wrap this up with one final thought that goes way beyond the textbook. These kidneys are absolutely remarkable, but they do age. In fact, by the time someone is 80, their functional kidney mass can drop by almost a third. So now that you understand their vital role as the body's master chemist, the question isn't just for your exam, it's for your life. What's one thing you can do today to protect these incredible filters for tomorrow? Something to think about. Good luck with your studies.